Today we will talk about sound pollution, the physical properties of sound, then sound power, intensity, and the measurement of sound. All of you are aware that decibel is the decibel level, courtesy the firecrackers and Diwali. So these are household names, decibel level. Okay. So sound pollution, we will talk about sound pollution. What exactly is sound, how it become sound pollution means, I would say that this is noise pollution. Noise pollution. Okay. Now, what is the definition of noise? Definition of noise. Noise is actually an unwanted sound. Unwanted sound. Now, this unwanted, degree of unwanted, in other words, noise is basically wrong sound at wrong time at wrong time and at wrong place. So, wrong sound, what do you mean by wrong sound? Wrong time and wrong place. Basically, this noise is psychological in nature. In nature. Psychological in nature. For example, wrong sound. For me, wrong sound is wrong sound, let us say, wrong sound. It is a subjective matter. Someone loves someone loves, say, Michael Jackson. For him, Michael Jackson, when he hears Michael Jackson, that is not noise. That is a beautiful feeling for him. And for him, when Amjad Ali Khan plays Sarod, it's a noise. Let's say Amjad Ali Khan. Amjad Ali Khan, or let's say Hari Prasad Chaurasia, whatever be the case. So for him, Michael Jackson or the kind of music like that is a sweet sweet thing for him. Whereas classical music like Amjad Ali Khan, Sarod, or Sitar Ravi Shankar, or whoever it is a noise. So it is basically psychological in nature, and wrong time, wrong place. This is also wrong time. What is someone getting up early in the morning and playing playing Raga Bhairavi right in the morning? For him, it's a melodious thing, serene atmosphere, things like that. And somebody who is sleeping late at night and he hears that music, it becomes a noise. So all kinds of controversy will be there. But anyway, assessment, we have to do assessment as far as the assessment of this damage is concerned. We will damage in the sense that you are going to lose your hearing faculty, kind of thing. So therefore, the degree of unwantedness is basically So we can write degree of this unwantedness is basically psychological in nature. But then what do we do then? Psychological is nature, so therefore there is not a universal solution for this one. Uh, since its effect is different for different observers, therefore um, we have to assess the uh, since the impact of noise varies from person to person, we have to come to terms with some moderate path. Assess the impact from moderate annoyance to permanent hearing loss. It may so happen. When actually the permanent hearing loss takes place, damage is already done. This is a basically this tool actually permanent hearing loss means it's definitely nobody can say that there is no effect on this. There is an effect. So therefore, uh, degree of unwantedness, all these things will be there. Unwantedness varies fine, but what we have to do now, we have to take a physical tool of measuring sound and uh, and define different kinds of sound. So now you have sources of noise pollution. Let's say noise of an electrical fan. Continuously is it's rotating and it has got a sound. Now let us say the discotheque. Discotheque dance. So different kinds of sound. Let us say moving train. This is another level of sound. So let's say you have a traffic. Another level of sound. Let's say you have a construction activities. Sporting activities, let us say stadium. So various kinds of, it may be low flying aircrafts, helicopters, stroke aircrafts. So different kinds of noises will be there. Now we have to Page number 2 plus, date is 24/1/2022. Make 4130. So these are the different sources of now the nature of sound. First of all, we have to uh, uh, physical properties of sound. Physical properties of sound. In plus 12, you have read about the physics, read about the acoustics, the sound. So you, well, okay. Physical properties of sound. Now, sound basically it's a wave. Propagating, oscillating, and propagating in a sinusoidal way. So, what is wavelength? Any two particles executing the same phase are in the same phase, consecutive two particles, the distance between these is called the wavelength, which we call it lambda. The maximum displacement, we are trying to measure sound. Maximum displacement is amplitude. So you have amplitude, we call it A. The maximum or minimum pressure range, pressure points, maximum or minimum pressure points. Either this point, or you can also take uh, crest to crest or trough to trough you can take. That is also the wavelength. Now, amplitude. Amplitude is the maximum distance. This is the amplitude, the maximum or the minimum pressure point. Then lambda, wavelength, the distance between successive two crests or two troughs, or any in fact you can also take some phase point in this, between this and this. Also, this is also the wavelength if they are executing the same phase. If they are executing the same phase, that is also wavelength. Now, period P, the time between two successive peaks or troughs. So period P is related by 1 by F F is the frequency. Frequency F cycles per second. It can also be said the number of complete pressure variations. Pressure variations means highest pressure, lowest pressure. So the in 1 second, whatever number of pressure, the number of upheavals will be there. That is also called the so P is equal to 1 by frequency and lambda is equal to C by F, where C is equal to speed of sound. The speed of sound at the sea level at 20 degrees centigrade, speed of sound in air at 20 degrees centigrade at sea level is approximately 340 meter per second. So vibration, that means if we want to sound or noise, whatever we may call it, the vibration is characterized by what are the things? Frequency, amplitude, phase. Frequency, amplitude, phase, etc. Now, a human, what is the hearing range? All of us know. Hearing range of human beings about 20 hertz to 20,000 hertz. One hertz is equal to one cycle per second. So 20,000 hertz. Now, this is our hearing range. Below this, we cannot perceive it. And beyond that, beyond 20,000, also, we cannot perceive that sound. So therefore, there is this is the range of this thing. These questions may be short questions will be there. One question, 1 marks per question. So these questions are important as far as your 1 mark objective type is concerned. Now we will talk about sound power and intensity. Intensity. This is important. Sound power. How do we define? The rate at which energy is transmitted transmitted by sound waves is called sound power. Let us say W. Power is always measured in watts. So therefore, sound power is measured in watt. 1 watt means what? 1 watt is equal to 1 joule per second. 1 joule per second. Joule means Newton meter. 1 Newton meter per second. Or you may call it 1 Newton means kg meter per second square into meter per second. So the watt, ultimately it becomes 1 kg meter square by second cube. This is the dimensional equation of. Now, how do you define intensity? How do you define intensity? Okay. Okay. What is sound intensity then? Intensity of sound average sound power per unit area average sound power per unit area is the intensity of sound, which is I. Therefore, I is equal to P is the power divided by area. Now, we know that when there is a sound source out here, it sound propagates in all the directions, right? Now, this is a sphere. Now, what is the per unit area? Therefore, what is the surface area of the sphere? What is the surface area of a sphere? That is 4 pi r square. Surface area of sphere is equal to 4 pi r square. R is equal to radius of the sphere. Sphere. Now, if you take R at this point, therefore, the this area, unit area, uh, will be the intensity. Therefore, I is equal to not P, W divided by 4 pi R square. W is equal to 4 pi R square. It can also be shown that intensity I is proportional to the square of sound pressure. Therefore, we can write I is equal to P square by rho C, where I is equal to sound intensity watt per meter square, P is equal to sound pressure. Remember, this sound pressure is continuously varying. Therefore, we have to take RMS value in Pascal. Sound pressure is Pascal. Pascal is basically 1 PA is equal to 1 Newton per meter square. Rho is equal to density of air or medium, you may call it. For air, rho is equal to 1.185 kg per meter cube at 20 degrees centigrade at standard temperature and pressure at STP. C is equal to speed of sound this is in meter per second. Now, how do we define decibel? One important parameter is decibel. How do we derive now? The ratio of weakest sound to the largest sound power without any pain is approximately 1 in 1 million. So a scale is chosen based on chosen a scale is chosen based on 10 times the logarithm of the ratios of the measured quantities to specified reference quantities. I repeat, a scale is chosen based on 10 times the logarithm of the ratios of the measured quantities to the specified reference quantities. Or in other words, mathematically, we can write LW is equal to 10 log W divided by 10 to the power minus 12 log to the base 10, where I think I'll be disconnected soon. I shall send you these notes today itself. I'll post it in your classroom. Please take a note of this one. I'll be logged out right now because it's almost time is almost over. So where LW is equal to the sound power in decibel in dB for 10 to the power minus 12